Hello, good day. This beautiful day to you all. Last week we started the topic bearing and distance, and we looked at the definition of bearing, various examples on how to locate the bearing of a point from another, and I also gave exercises, which I've also done a video on the correction to the exercise. I believe you've seen those videos. Please watch them again and again until you understand it. This week, my focus is going to be on the second method of measuring or calculating bearing of one point from another. And this second method is known as three-digit bearing or Sauvigne's method. I believe you still remember the method we discussed last week. And if you do, can you remind me the method? Yeah, what is the name given to that method again? Yes, you can answer. Correct. That is very, very correct. It is called compass bearing. Compass bearing. Wow, you guys are smart. So this week, like I said earlier, we're looking at the second method of representing bearing. So it's called the three-digit bearing or the Sauvigne's method. So this involves using three-digit numbers. The angle is measured from the north in a clockwise direction. If angle measured is less than 90 degrees, that is, for example, 4 degrees, the bearing is written as 004 degrees. These are other examples of three-digit bearing: 055 degrees, 265 degrees, 107 degrees, etc. So the simple concept behind compass bearing is that we want to neglect the cardinal points, the north, the south, the east, and the west. We really want to write our bearing in form of just digits, three digits, no N, E, W, S. Now the question now is, how do I resolve? How do I convert from compass bearing to three digits bearing? Now, these are the rules. Look at the right side of this lecture. I'll quickly show you the rules. So here are the rules of converting or for converting from compass bearing to three digits bearing. Please pay maximum attention. And it says rules for converting from compass bearing to three digits bearing. And let's take theta to represent any given angle. Any given angle. Okay? Now this is my north. This is the north, south, east, and west poles. Now the rule states that if any bearing or any points fall between the northeast of the reference point, any points lie between this region, anywhere around this region, anywhere around this region. Of course, you know that the points lie between 0 to 90 degrees northeast. So all we need to do is to add two zeros or a single zeros depending on the given angle. For instance, if the given angle is say 5, if the given angle is say 5 degrees, excuse me, where is my pen? My pen. If the given angle is say 5 degrees, then 5 degrees, then the bearing in the equivalent of north 5 degrees in three digits bearing is simply written as 005. Again, if the bearing is, let's say, north 48 degrees, the east, north 48 degrees east, the equivalent of north 48 degree east in three digits bearing is nothing but 048 degrees. Very, very simple. Isn't it simple? Of course it is. So if any points lie between the northeast region All you need to do is either you add up two digits if it's a single digit angle, or sorry, two zeros if it's a single digit angle, or 10 if it's a two digits angle. Having said that, let's come to the next region, the east south pole. Now, if any point lies between this region, the east south pole, meaning that if you have the point like this, and that point lie the cardinal point, so it's going to be drawn like this. It's drawn this way. So it falls between the east south pole. All we need to do, the rule there is this: whatever angle it is, whatever value it is, whatever value it is, that is, and note, please mind you, the angle must be joined from the line joining that point, whatever point it is, to the south pole. Whatever it is, subtract that angle from 180 to get a three-digit bearing. Subtract the angle from 180. Any angle, any point that lies within the southeast region, subtract the angle from 180 degrees to resolve it to three-digit bearing. In this case, we don't do any subtraction. In the northeast region, we do no subtraction nor uh, nor addition. All we do is add a single zero or three zeros. Remember, but if the points lie within the southeast region, what we need to do is subtract the angle from 180 degrees. That is the rule. Please don't forget. Now let's move to the southwest region. Any points that lie within the southwest region, any points that lie within the southwest region, and if you're given the bearing in compass bearing, or as the compass represented as in compass bearing, to resolve it to three-digit bearing, what do you do? Add the angle to 180 degrees. When you add that angle to 180 degrees, you resolve it to a three-digit bearing. Finally, if the points lie within the northwest region, the angle given there, subtract it from 360 degrees to resolve it to a three-digit bearing. Okay, let me take again. If the points lie within the northeast region, do no subtraction nor addition. Simply add zero, single zero, or two zeros to convert it to three digits bearing. If it lies between the southeast region, subtract the angle from 180 degrees. And if it lies between the southwest region, add the angle to 180 degrees. If it lies between the northwest region, subtract from 360 degrees. Having said this, let us answer the question that follows the example. The example says, complete the table below. Position A, you are given the compass method, the compass bearing method of position A as north 46 degrees east. So what would the three digits bearing be? North 46, going by the rule. North 46 degrees east should be what? What do we do to get it? Good. Add a single zero before 46. It is that easy. So north 46 degrees east is simply 046 degrees, three digits bearing. 043 degrees, 046 degrees rather. So I hope you're following. Right now, we want to convert from the second one, question 2. Position B is given as three-digit bearing. So how do you think I can convert from a three-digit bearing to a compass bearing? So what do you think we need to do? Of course, perfect. Now, since we convert the angle from, 3 to 6, we fall somewhere around the northwest region. The northwest region. Now, let me see this again before we proceed. If you check this arrow, the arrow I drew with different colors. Here, blue from this point from the North Pole to the East Pole is 90 degrees. From this pole to this pole is another 90 degrees. Please, what will be from the North Pole to the South Pole? Yes, any idea? Perfect. That will be 180 degrees. So it means any angle that is greater than 90 degrees but less than 180 will fall in this region. Similar way, in like manner, any angle that is greater than 180 but less than 270 will fall in this region. So everything between 180 and 270 lies in this region. But from this south pole to the west pole is also 90. Please, are you following? Now, similarly, any angle that lies between that is greater than 270 but less than 360 lies in this region, or 360 exactly is equivalent to 0. So now this angle is given as 324, meaning that is an angle that lies within the northwest region. 324 lie within the northwest region. Please, is that taken? Northwest, somewhere around here. So and the rule is to subtract the given angle from 360. Subtract the given angle from 360. So subtract that given angle from 360, what would that be? This is subtraction. 360 minus 240 we give what? Sorry, minus 324 rather. 360 minus 324 we give what? Of course, 36 degrees. So that will be 36 degrees, okay? I hope you are with me. Yeah, it's making sense. All right, so since this gives 36 degrees, that means the compass bearing of equivalent to 324 3 bearing is nothing but north 36 degrees west, north 36 degrees west. All right, okay, that is making sense. Next, north 85 degree east. Of course, it also lies within the northeast region. All we need to do is just add a single 0 and write 85 degrees. And it's that simple. Next, south 27 degree east lies within the region that is from 90 to 180. So what is the rule? What's the rule? It falls in the east to southeast region. What is the rule? Subtract 27 from 180. So since it lies in the southeast region, subtract 27 from 180 to get the 3 digits bearing. So here is 3, and this is left is 7, and this is 5, and here is 1. That is 153 degrees. 153. Perfect. So you see, we resolve it to 3 digits bearing. Very simple. Then next we have 178 degrees. This also lies in the southeast region. So what do you think we need to do? Carry out the same rule. Perfect. So subtract the angle from 180. Subtract the angle 178 from 180 to get the compass bearing. So and that will give just 2 degrees. So this is south 2 degrees east. South 2 degrees east. Finally, last but not the least, we have north 7 degrees west. North 7 degrees west. This falls within this is northwest. It falls in this region. So the rule is subtract it from 360. When you subtract 7 degrees from 360, that will give 353 degrees in 3 digits bearing. So with this, I believe you understand 3 digits bearing now perfectly. You understand compass bearing. If you don't, please watch this video again and again, and also try to understand the idea, the rules for converting from compass bearing to 3 digits bearing. All right, please watch it again and again for better understanding. Thank you for your attention.